So thank you very much for coming to today's workshop. We're focused on the cloud today. And in particular, I'm going to walk you through the process of logging into the West Cloud, also known as Arbutus, for a first time, assuming you've never done this before. And we're going to go through the process of creating and logging into your first VM, which is the acronym for virtual machine. Just before we do that, I'm going to give you a little bit of background on the cloud. In terms of the time that this will take, I'll probably talk before we actually get to the hands-on part for maybe 5-7 minutes to give you a little bit of background, and then we'll shift into doing a hands-on portion. So I'll drop the slideshow then, and I'll do everything live in front of you. You can just watch and follow along, and following along could be just watching me, or it could be you trying to do it on your machine as well. Feel free to ask questions if you get stuck partway through the middle. But this is also recording, so you can watch it again, and if you'd like, I'd be happy to meet with you on a one-on-one and walk you through it if there's some hiccups there. One thing that I overlooked when I sent out the announcement for this was that we will be using what's known as the shell or the terminal or the command line for part of this. If you're following along on an Apple machine, so you're using OS X, or you have a Linux machine, this is already built into your operating system. If you don't have it, if you have Windows and you don't have a shell installed, you could install one now. A great one to just download and use is called MOBA Xterm, but I don't have the setup to show you how to do that. So if you're using Windows, you can download MOBA Xterm, and you might be able to follow along, and if not, then send me a note and I will meet with you afterwards and I'll walk you through the process for that. It should be about the same. So here's a short overview of Compute Canada if you're not sure quite who we are. Roughly, we're the umbrella organization in Canada that's responsible for coordinating with our regional partners to deploy high performance or supercomputing power for researchers. There's roughly 200 of us distributed across the country, and we're usually attached to research institutions like universities. And our reason that we're here is to help researchers do their research, right? We want to take people beyond the desktop. And traditionally that meant cluster-based computing and parallel jobs, but increasingly it's meaning the cloud. And this opens up computer power at a scale that wasn't available to a lot of disciplines that aren't used to doing cluster-based computing. So I'm the Humanities Social Sciences Specialist for Compute Canada. A lot of humanities and social sciences researchers are really interested in what they can do in the cloud because it gives them access to websites, they can create web portals and so on. So we'll talk a little bit about that. It's helpful to know who has access to these resources I'm going to talk about today. So on the grid that you're seeing here on the screen, you'll notice that there's two types of accounts. There's a PI or Principal Investigator account, and there's also a sponsored account. The resources I'm going to show you today fall into what's known as, say, a default allocation. It's not really an allocation. We now call it a RAS, R-A-S. That stands for Rapid Access Service. And this is just a pool of resources that are available to all researchers, regardless of whether they have a special permission to use large quantities of resources. So if you're an undergraduate student and you have an account with us, you're a graduate student, you have an account with us, and so on, you'll have access to the things I'm talking about today. The only difference between the PI accounts and the sponsored accounts are PIs are able to apply for much larger amounts of resources, and sponsored accounts need a PI to sponsor them, hence the term sponsored account. This is what Compute Canada looks like, and when I mentioned the 4 regions before, the one that we're doing today is sponsored by WestGrid. Technically I belong to WestGrid, but we're such a happy family that we're all just happy to be together as part of Compute Canada. Just before we get into the cloud piece, this is the last slide on things that you may need to know. The website to get an account, if you do not have one already, you won't get your account fast enough to follow along, unfortunately, but it would let you move forward, is ccdb.computecanada.ca, and you can log in there to create an account. If you have any problems during that process, you can send an email to accounts@computecanada.ca. And if you want more information, you can also go to WestGrid directly with info@WestGrid. So let's talk about the cloud. So the cloud system that we're focused on today is Arbutus. It's also known as GP1 for General Purpose System 1. It was one of the first new systems that was granted to Compute Canada, and Arbutus is the name that was chosen was just chosen for it. So, and it's been installed and operational since about 2016, and it's got about 7,000 cores. Some of them are shared in various ways, so you get up to, looks like 16,000 cores on the machine, and it's getting a whole major upgrade in terms of upgrade in the sense of additional cores and additional storage that's being added onto it. We'll have petabytes of storage and thousands of more cores are being added right now. And so what researchers are able to do with this are log in to the system, and they're either able to do kind of cluster-based computing because they can use it just to do raw compute, or more of what a lot of the system was intended for is to be able to run things like websites and portals where people can come in and they can do research on the system, but through their web browser. So they can log in and access databases. They can log in and submit research information and have that data crunched in the background and then sent to another database or given back to them, and so on and so forth. What's very important to know about the cloud service that we provide is that what we are providing is called infrastructure as a service. And so this is, the acronym for this is IaaS. And so if you hear people talking about IaaS, that's what they're talking about. So what does this even mean? Well, legacy IT is sometimes referred to as legacy IT or enterprise as a service. And on the far left side of the slide, that's the full software stack. And so this is who's looking after these things, right? Well, this is kind of everybody, right? So this is you're responsible as a customer, you're managing your applications, your security. When you're given a desktop machine with just the operating system installed, or even just a machine, you're kind of stuck doing that. Your enterprise IT system will look for it. Infrastructure as a service only looks after half of that, right? So you're responsible as the customer for infrastructure as IT, for installing your applications, looking after your security, your databases, your operating system. You are going to install that. And we'll go through the process today of showing you how to put those things on the machine and in place in the most vanilla, straight out of the box way possible. What we look after is we look after the servers and making sure that they're plugged in and that the networking is working in the background and that the drives are there to hold the data. So it's not like you're actually holding your machine, you're just responsible for doing this install in the cloud. Sometimes you'll see something called platform as a service, and we're slowly considering and possibly moving towards this for some applications where we look after a whole lot of things in the background to make it easy for you, because as researchers, you don't want to have to be worried about security and did you update all your virtual machines for the newest hack or software bug, or it's just something that's taking away from your research time. So if we can bring that in-house and you don't have to worry about it and it makes everybody on the system more secure because it is a shared resource, then that's a good thing. And then at the end, some vendors provide software as a service.
I have a scan to do, like next week. Do I need to book an appointment?
So I'm hearing somebody in the background. Is that a question for us?
I think not. I just muted.
Oh, sorry. Thank you. Sorry, I'll go back to the slides then. So today we're doing the service that we provide right now is Compute Canada on all our clouds is infrastructure as a service. And so you're responsible for applications, security, databases, and the operating system was put on there. So we'll go through the basic version of that today. The tool that we use to do this is called OpenStack, and it's the open source cloud management system, and we use it to provide the services to the researcher. So we're almost at the hands-on portion. These are the resources, the raw resources that are available to people as part of the rapid access service, so what we might otherwise call a default allocation. So you can, as a researcher, have access to up to 10 virtual machines or virtual CPUs, 45 gigs of RAM, 2 external IP addresses, and a terabyte of storage. So for researchers that are just building a web portal or a web service, or they just want to run a website to showcase their data, most of the time this hits a really nice sweet spot and further resources aren't needed at all. So ideally this works for all of you today, and if it's not, there is a process for applying for larger sets of resources, and we can go through, well, we can talk to you about that. You can send an email to info@WestGrid and they'll help you out, or any of the other ways of contacting WestGrid or Compute Canada. So we're going to move to the hands-on portion, and I'm hopeful that you're able to log into one of these sites. Now to do this, you're going to need a Compute Canada account, and B, you will have needed to send an email to cloud@computecanada.ca requesting your cloud access to be turned on. And the reason for that is, unlike all the cluster systems in Compute Canada that are connected directly to your accounts and you get access to them as your account's turned on, with Compute Canada, the cloud system still runs as a one-off. It's still being built up, and so you don't get an account there by automatically, although you can have one there just by having an account with Compute Canada. So if you do have a cloud account, when you got it, you would have been told to either go to east.cloud.computecanada.ca or west.cloud.computecanada.ca. West.cloud.computecanada.ca is Arbutus. It's at University of Victoria, and east.cloud is at the University of Sherbrooke. It'll basically be identical for what we're walking through today, but you'll want to direct yourself to the first one. So this is where I'm going to step outside of the presentation, and I'm going to move to a hands-on portion, and I'm going to do everything live so you can see it happen. So hopefully you're able to follow along. So give me about 30 seconds here to swap over to that environment, and away we go. This is a great time for questions if you have any as I'm swapping over. Are we doing okay? Let's see. Oh, there's, okay, we're okay. Okay, so when you get your account and you log in, when you get your account and you go to West or East, you'll see a screen that looks like this. Or if you're East Cloud, it should say East Cloud instead of West. My username and password have already been filled in. You're going to need to add those for you. They should just be your Compute Canada username and password. And then you're going to click Sign In. And it'd be really nice at this point if you were all done, but there's a few things we're going to have to do beyond just signing in. So what you'll have when you log in is you should see an overview here. It should be like a dashboard. Now, if that is not the case for you, then out of the menu on the left-hand side of the screen, under Compute, you're going to want to make sure that you've got the Compute menu item expanded and that overview is chosen. Most of these should be, actually, if it's their first time logging in, these should pretty much all be pretty much blank for you. You shouldn't have any floating IPs. You might have one security group that's active. You won't have 3. This is because the reason you're seeing a few differences here is I'm using an account that we often use for training, so it's going to have resources beyond what you have, but for the most part it'll look the same. So an instance is a virtual machine that you have up and running, and so a virtual machine is a combination of CPU, memory, storage, and some security rules. And currently you'll see I don't have any up and running, but I have 50 that I could possibly draw on. Virtual CPUs, these are the actual number of CPUs that are used, and if you have 1 CPU per instance, these will match, but a lot of times you'll have more CPUs, so you might use 5 CPUs in one instance, so you'd say 5 here and 1 in the instances. RAM is how much you've used. A floating IP is a numeric address on the internet that allows people outside of the cloud system to find you. It's the equivalent of typing in a URL. It's actually what a URL will resolve to. All those words will all turn into a set of numbers, and those numbers are addresses that point to certain machines. And we'll give you up to 2 of those, which is really attractive for people because you don't have to pay for them. Security groups, there's different services that you're going to want to provide, and we'll go through how to set up some simple security group rules. Basically, we're going to open up holes in what's called a firewall. And by default, the firewall rule is let everything out, let nothing in. And this isn't going to work well if you want to have a web server and you want people to see your web page, because anytime somebody from the outside wants in, they're going to need to go through the firewall. So we'll show you how to open holes in that. A general good principle here is don't open anything in the firewall you don't need to. So there are some options that will open all the ports. This is a great way to have your system be hacked. And unless you want to first make a donation to Bitcoin miners, and then 2, have your VM shut down by us, it's a good thing not to do. Volumes, this is what we call the disks that you can create storage on. And you have both a limit on the number of volumes you can create and the total number of storage that you can assign to each volume. So what we're going to do is we're going to walk through the process of creating an instance so that you can actually have a virtual machine running. So before we do that, we'll go through the other options that are here on the side just so you can see them really quickly, and we'll add a new security group for you because you're coming in cold. So we'll ignore the ones I've already created and we'll treat it like I don't have any security groups. I shouldn't have any instances running. This would show me the virtual machines if I had them. Maybe you do already. Maybe you're in a shared project or tenant space. I don't have any volumes running, but this would be the disks that I have spinning. I do have an image that's stored here. You have the ability to take snapshots of the systems that you set up and put them aside so that you can make copies of them again in the future. And so I have one left over from that, and that's what this image is called. And then the last tab here in Access and Security is where we're going to set what's called our private keys. We'll do that when we create the instance. It's also where we create our security groups. And so I have 3 security groups here right now. One that allows web access, a default one, and this is the one that locks everything down. And I have one that allows Jupyter notebooks to be run on this server, because sometimes we'll run Jupyter notebooks. So the first thing we're going to do is we're going to create a security group that's going to allow SSH access. SSH stands for Secure Shell, and it's the way that we get inside the virtual machine through the command line. So you're going to see that happen in just a moment. Hopefully you're able to do it yourself. But before we do that, we've got to punch a hole in the firewall that allows SSH. So to do that, in the top right corner, it says Create Security Group. I'm just going to click on it, and I got to give it a name. It's got a little star beside name. It's going to force me to do that. And I'm just going to call it SSH. I'm not going to give it a description. SSH is all it's going to be able to do. And I'm going to choose Create Security Group. In the bottom, it says, bottom of the screen, it says it's waiting for WestCloud to do something, and it will. And when that's done, I should get a new security group. Top right corner, it says successfully created security group, SSH. Here's that security group. And if I come in here and choose Manage Rules, let's see what it did. Well, I've got 2 rules, and these are the egress rules. These are the ones that let things get out. And just because I called it SSH doesn't mean that it's actually going to let SSH traffic through. So I need to come in and I need to add a rule. So in the top right corner, I'm going to click Add Rule. Now the trick here is, it looks like you have a lot of options here, and the trick here is not to pay attention to any of them but the first one, unless you really know what you're doing. So here I'm going to pull down the option for the rule I want to choose, and at the very, very bottom of my screen, or the very, very bottom of the menu, is SSH. So I'm going to choose that. It's going to set everything the way it needs to be. I don't need to play with anything else. I'm just going to click Add. going to work on it for a moment or two. And I now see a third rule. I see the first two for egress, which allows content and me to access things to move outside the firewall. That's essential. But I also have this new rule that's going to allow ingress. It's going to allow outside traffic into any virtual machine that has this rule set called SSH attached to it. And so we're now ready that we have our security group with SSH access to create our first instance. So I'm going to come up here to instance, and I'm going to click on it. I'll ignore the Microsoft Office helpfulness there, because it's not the Mac OS helpfulness. And what we're going to do is we're going to come to the top right corner, and we're going to choose Launch Instance. So, Launch Instance. We're going to have some options here. So the first one is the Details tab, and it's the first one that comes up. We have an availability zone. These are zones available within the cloud. You should only have Nova as the option. You can just ignore it. You're going to have to give your instance a name. So I'm going to call mine WestGrid Webinar. And then just so there's a date, May 2018. You can call it anything that you want. Now we have what are called flavors. And you click the little question mark here, right? Put your pointer on top. It'll tell you the size of the image to launch. And size is size in terms of the number of cores. So how many virtual CPUs, the type of those CPUs, and how much RAM you're going to attach to it. So this is the short-term memory for the computer. So for us today, we're going to make it pretty small. It doesn't have to be a big machine at all. We're just vanilla flavor testing here. So I'm going to choose P1 1.5 gigabytes. Now that P stands for persistent, and persistent are the cores that are intended to run a web service, particularly in the research environment. They sit there a lot of the time, they're just waiting for something to do, and they're on nodes with other cores, and those cores are heavily shared amongst a large pool because most academic websites are not being pounded constantly. If you need to do actual compute and you need a higher level of dedication within the core, then you can choose the C nodes. But for today, I'm going to choose P1 because I just need one core just to start a basic virtual machine, and I don't need a lot of RAM, so I'm going to go with 1.5 gigabytes. I can launch multiple instances, but here I'm just going to start with one instance. And then the last option on the details screen is boot source. If I already have an image, and you saw that before, this is a machine that I built in the past. It's got all the setup of the operating system. It's all done in there. I can just boot from that image. I can boot from snapshots, and these are pictures of VMs at times. Sorry, the image is pre-built, so sometimes we'll have those for you. Snapshots are pictures of virtual machines that you've taken of your own virtual machines that you can reload from. We can boot from a volume if we already have a volume that's built, so a disk that's sitting off on its own that doesn't have any compute guts attached to it. But we don't have anything like that right now. We're just starting. So I'm going to boot from image and create a new volume is the option that I have here. The moment I choose that, I get to choose what the operating system is. So what's the image name is choosing the operating system. For us today, down at the very bottom of the list, we're going to choose Ubuntu Server, and we're going to choose the 1604 flavor. We're just going to use Ubuntu because it's a pretty standard Linux system. You'll notice that most of these options here are Linux. There are a few Windows servers. If you want to use Windows, we strongly recommend that you contact the cloud team in advance. Sometimes there's setup that they have to do in the background. And there's also a licensing issue for Windows. We are working very hard with Microsoft to solve that licensing issue. I actually have a meeting with them this afternoon. And hopefully you'll be able to transfer or otherwise acquire an academic license to run Windows content on these machines. So we're very close to that. So choose Ubuntu server 1604 down at the bottom of the list. The device size in gigabytes, well, if you leave it at 1 gigabyte, it's probably going to fail. So why don't we make these little 10 gigabyte machines, and we're just going to clean these up when we're done with them. So the last option is delete on terminate. So this question is asking, right, if you hover over the question mark there, do you want to delete the volume, the place that holds all your data when you terminate the virtual machine, which is the core, the CPUs and the memory? If you got rid of those, which you might want to do, you might want to keep your data and throw away the first set of cores and memory that you built because you now want something bigger, or maybe you need something smaller. So that's an option there. But today we're just going to destroy it all as a single package when we're done. So I'm going to choose delete on terminate. I can't click launch yet because I need to do two important things here in access and security, and then one thing in networking. So the first is we'll come to the bottom and we need to choose our security group. You should have two security groups. You should see default and SSH. Default will be turned on, but remember, by default, it only allows traffic out. It doesn't allow it in. So we created a new security group called SSH, and we can combine them here. So you could use default and SSH. There'd be a little bit of redundancy here. I'm going to take off default, just use SSH. The next thing we need to do is this key pair. Now, I can right-click here, and I can click here, sorry, on the menu, on the arrows on the right, and I already have some keys made. It's really likely the case that you do not have any keys made. So I'm going to go through the process with you now of making those keys, and this is where you're going to need a terminal. So we're going to start by clicking the plus button on the right. I'm going to need to import a key pair. So I'm going to build a key pair on my machine. You're going to watch this happen. Hopefully you can follow along. And then I'm going to copy and paste that key pair into here. And what that's going to do is I'm going to have a really complicated string of text that's going to be my public key. And I can use that. I can put that places. I can share that with anyone, and they can use it to lock content down. It locks the content down in such a way that the only way to really easily open it is to use my private key, which I keep secret on my machine. And so we're going to lock our virtual machine with our public key. We're going to unlock it with our private key. So I'll call this WestGrid webinar key May. Well, it's not May yet though, is it? I made a mistake before. We'll call it May 2018. And this space here is where I'm going to copy and paste my key pair in. It tells you how to create the key over here on the right. So we're going to kind of follow along with that. What I'm going to do is I'm going to bring up a terminal window. If you're following along in Linux, you know how to do that. I'm assuming you do, and there's so many different Linux flavors that I can't really go through them all. If you're following along on a Mac and you've never opened this before, the easiest thing to do is hold down Command and press space, and this will bring up the Spotlight search, and you can type terminal, right? And the terminal will look like this little black box with a greater than symbol in the top left corner, and you can just open it by clicking on it here. If you have Windows and you downloaded MOBA Xterm, you'll need to open MOBA Xterm, and there's a blue button at the top when you do that says start a terminal window or something like that. So I'm going to open this. I'm going to double click on terminal. It's going to open a terminal window for me, but it opens it in my other window, so I'm going to have to drag it over here so you can see it. Now, I'm really hopeful that the text is big enough for you to see. So this is the command line. We're not going to go through a whole lot of features here on the command line. However, I am going to show you a few things just so you're feeling a little bit comfortable with it. So one thing that we can type in here is ls, and this is to list the structure of the directory. And this is going to be important for us. Right now, you're in our home directory by default, so you'll see I have a whole lot of files that's in here, right? I've got a thing called downloads, my documents folders in here. This is where my desktop folder is and so on. And I've got a bunch of other junk files too. You'll have more or less files depending on how you use your home folder. And I have a lot to clean up, I'm sorry. So now that we can see what's inside, that means that we can see the differences as we start to do things. So here, we're going to want to use this. ss-keygen-t rsa-f cloud key. So we're going to basically be copying and pasting this in, but I'm going to type it out and I'm going to explain to you the pieces as we do it. So ssh-keygen. So this is a command to generate an SSH key. I'm going to tell it what type of key I want it to produce. So I'm going to put a space between keygen and this -t, and that's just at the part where we had put in the SSH keygen command. We're generating a passphrase for this. It's asking me to put the passphrase in a second time. And so I'm going to do that. Oh, they didn't match, probably because of the hiccup. And there we go. We should end up with a nice random art image that shows up at the bottom of the screen. And this is a way of fingerprinting. And we don't need to talk about that right now, so we won't. But remember I showed you the ls command before. And so if we put the ls command in again to list the contents of the directory, we'll see that there's 2 new files in here that weren't there before. They are here, right? So here I have a thing called cloud key, right? And I have one called cloudkey.pub. Now, there's all sorts of places, well, there's one particular place you're supposed to put these, but they're just generated in my home directory right now, and that's okay for the purposes of this demo. What we need to do is we need to look inside them, right? I need to take that public key and I need to copy it up. We're going to do that through a copy and paste mechanism. So the command for listing the contents of a file is cat, right? So it stands for concatenation, and we're able to stitch files together, but we can just pass it a single file and it will print the contents of that file on the screen. So cat space cloud dot key dot pub, right? Because this is the public version of the key. So I'm going to paste that on the screen. And what I need to grab is everything from the first S all the way to the end of the name of my machine here. And so it's here at Simpson at MacBook-Pro-2.local. So I need that whole thing. So I'm going to copy that whole thing. So I'm going to highlight it. And I'm just going to use Command C. You can use Control C, or you can right click on it. Depends on the tool that you're using. We need to copy this. And I'm going to go back to my browser window. And I'm going to paste this into the public key. I'm going to go Command V here. It could be Control V for you, or you can right click and paste or choose paste from the edit menu if you'd like. And this is my public key. And so we use the public key to lock our virtual machine so that only our private key can open it. Now it's really important here that you have the entire key and nothing else but the key. So if there's an extra space at the end, that's a problem. So I just put a space in here. I got to take that out. Sometimes there's an extra return in there. That's not okay. That'll be taken as part of the key. And the moment you do that, your private key doesn't fit anymore. So it has to be the private key, the public key, and nothing but the public key. So we paste that in and we choose import key pair, right? And so now we're back at our launch instance window. We have our key pair name. I called mine WestGrid Webinar Key, May 2018. I've got my security group open. Come over here for networking. You should have a cloud network option available here. If not, there's be an option in available networks. You should be able to just drag it up. That's already happened for me. We don't need to do anything post-creation. Here's a place where you could put some scripts and it would do a whole lot of work for you automatically. And we're not going to pay any attention to the advanced options in terms of partitioning disks, which is different ways of dividing up disks and so on and so forth. So at this point, we've got our details screen filled in. We've done all our access and security. you have a network, right? And it's pulled up here. I'm not sure what yours is going to look like here. I'm sorry for that. And we should be able to choose launch. And it will go away in the background and work. And it'll keep working. And ideally, you get a little green window up here that says success, and then it's launched your instance. And you can see you see its instance name. Doesn't have an IP address assigned to it yet. We'll get to that in a moment. It has a size that you chose. It tells you what key pair has been attached to it. You can see that you've got these little kind of barber pole that's showing you that it's working here, that it's scheduling and mapping out your virtual machine. And it hasn't actually been up yet, so it's still working along. While it's doing this, though, we can associate a floating IP. And this is that outside address that's going to allow you to access your machine from outside in the world and other people as well. So we're going to, if you don't see the associate floating IP option, you can click the little arrow here under the actions and it should show up. So I'm going to click associate floating IP. Now, I already have some IP addresses that I could use because I've already done some work here, but you won't. So you're going to have to click the plus button. When we click that plus button, it's going to do some additional loading. We're asking it to do a fair bit right now, so we got to wait just a moment. And there's a pool that it'll draw from, and you won't be able to control what that pool is. But what you want to do is choose allocate IP down here in the bottom right corner. And here it says that I'm using 1 and I have 49 available. Yours will probably say that you're using 1 and you have 1 available. You can have up to 2 if you make that request. So we're going to allocate that IP address. It's going to work away. I now have an IP address in that box. It's 206.12.101.160. Yours will be different because they're all different addresses for different machines. And I'm going to choose associate in the bottom right. We don't need to worry about the port that it's associated with. It'll handle that cleanly on default. So I should see a green success window up here on the top again. The window will do a little bit of reload. And I should be able to see the IP address show up here alongside the internal one. So I'm just going to reload the window because it didn't seem to do it. There it is. So you have 2 IP addresses. One is the local IP address within the machine itself, and that'll start with a 192. And the other one is the external IP address, and that starts with a 206. So we are moments away from being done here because all we're going to do now is we're going to take this external IP, the floating IP address. I'm highlighting it here. I'm going to copy it. So on the Mac, that's Command-C. On a Windows machine, it would be Control-C. You can also choose it from the Edit menu. I'm going to come back to my terminal window. And this is what I'm going to, the standard way to access a machine with SSH is to type SSH and then the address of the machine. But we're going to pass it 2 other pieces of information here. So a standard one might look like this, SSH and then your IP address. But that's not going to work for us right now. And if you type that in, it's going to fail. And you can just let it fail out on its own, or you can hold Control and press C to cancel that option. What we need to type here, is SSH. We need to tell it what key to use. So we need to pass it the identity flag. So SSH space and then dash lowercase I. That's the identity flag. And we need to tell it what key to use. So I want to use my cloud key. And because I'm in the same directory that the key's in, I don't need to tell it to look anywhere special. So SSH space dash lowercase I space cloud key. So use the SSH command with the identity flag, go get the cloud key. We created a VM using a flavor of Linux called Ubuntu. So that's my username, Ubuntu. And depending on what virtual machine or what operating system you create, it's going to change the name. So you're going to have to know what that is in advance. And if you're not sure, you can ask us. You can also find it on the web. So my username is going to be like an email address. It's going to be Ubuntu at, and so that's the ampersand. It's just above the 2 character with the shift. And then I'm going to paste in my virtual machine ID. Right, so 206.12.101.160. And again, yours will be different. If you try to use mine, it's going to fail because you don't have, or should not have, my private key. And once we've done this, I'm going to press enter. It's going to say, I've never seen this before. Is this the machine that you want to access, right? And it's going to provide you with a fingerprint. We know this is the right one. We're good. So I'm going to type yes, and I'm going to move forward. It's going to add it to the list of known hosts. So this is machines that I know and trust, and that list is stored on my computer. And now it's asking me for my passphrase. So I type that in. And if we're successful, we should see a welcome message show up. And now we're inside the virtual machine. So it looks like I'm still in the terminal, because I am, but it's not the terminal that affects my local computer anymore. I'm now in the remote system, accessing the Arbitus machine at the University of Victoria. And so, yeah, that's where we are. Now, just before we finish off this and move to some questions that I'm going to transfer over to some other people to answer, because I have to run and actually run another session. I want to emphasize that if you're using Ubuntu or any flavor, that there's another step that you need to do. And that is update the images that are here. And we do that for security because we've got these images, but there are things that could have happened between now and then, holes that could have been discovered, and ideally they get patched. And because we're using infrastructure as a service, you are responsible for the security of your virtual machine. So I'm going to show you how to do that in an Ubuntu VM. It'll be very similar on the other Linux flavors. The Windows ones, well, we can talk about separately. So I need to have special status to do this, and so I need super user status. So a command that I need here is super user do. Now, a lot of times you need a password for this, but the way we've set up these machines, because you're using the SSH key, we're trusting that you're already identified. We know who you are, so you can just type this in. You won't need a password for it. So it's sometimes called passwordless sudo, and sudo stands for super user do. So I want the super user to do something. So I put a space in. What I want it to do, I want it to use a tool called apt-get. It stands for aptitude get. And it's going to go to a special list, and it's going to do what? Well, I'm going to put a space in. I want it to update. It's going to update a list of all the files that are available, all the programs that I can download and that are installed on my machine. So I'm going to run that, and it's going to go off on the internet. Remember, we allow any traffic out, and we're allowed to pull this information back in, and it's going to pull up the update for all the libraries. So the first one is sudo apt-get update, and the next one is sudo apt-get, and I'm just pressing up here on my keyboard. It might look like I'm typing really fast, but I'm just cycling through the past commands. If I actually want to make the changes, it's upgrade. Sudo space apt-get space upgrade. And if I run that, it'll actually run through the process. And then the very last thing that I'll do is sudo space reboot. And that'll just restart the machine, just like you would restart your actual desktop or your laptop, and apply all those changes. I'm not going to do that here. It would not be exciting for you to watch, and it wouldn't be helpful for you at all. So I would run sudo apt-get upgrade, and I'll start that now, just so you can see it start. And when that was done, I'd run sudo space and then just the word reboot for reboot. And that's, oh, you might say yes. Do you want to do any of these operations? And you just reply with a yes. And if it's a capital Y, you need to put a capital Y in there just to make sure that you're serious. So I'm going to turn off my screen share. You have an error from Sasha. It's quite possible, Sasha, that I'm guessing here, and we can follow up afterwards, that your error with that block device mapping being invalid is perhaps the size of the virtual machine, or not the virtual machine, the storage that the volume is too small for the virtual machine that you chose. Now, if you chose everything that I chose, then it's going to be something else, and I'd be happy to chat with you after directly so that we can solve that problem for you. JF is 98% sure it's a volume size there as well. So if you go back and go through the steps again and make it bigger, it might work.
Thank you.
Unfortunately, block device mapping is invalid is not a helpful description if you're not used to that error. So I'm sorry about that. So Mark, JF, and Garth, we had a hiccup in the middle here, so we're probably 10 minutes-ish longer than was my intent, and I've got to run and do another workshop. Is it okay if I pass this over to you right now? I apologize to everybody who's here that I've got to run away.
It was fantastic. Yeah, we'll handle all the questions. Hopefully, Jean-Francois can stay for a few more minutes.
Super. And if there is anything that people like to talk to me about after, my email address is john.simpson@computecanada.ca. You can send me questions directly, and I'll follow up with you as well. So thanks very much.